Our next speakers are Philip East and Stephen Hughes, who are from across the border at University of Northern Iowa. And they're going to be talking about do it till you get it right. Sounds intriguing.
Okay. The original title of this that I submitted was Competency Demos of Programming Skill. The committee said, oh, we don't know what the heck that is. So they titled it, Do It Till You Get It Right. And so that's what we're doing. My name is Philip East. My colleague Stephen Hughes and I have been trying to better understand, both understand computer science, or programming rather, and, okay, let me start over again, understand teaching of programming and to improve our practice of teaching programming. And there are two different things. Some people teach well and don't know what the heck, how they do that. I don't teach well. I want to understand how I might teach better, so I have to work at understanding. Some people just do it naturally. And so we've been working on this for a while, and we have a number of recommendations or things that we have been using. We started this with thinking about a problem orientation to teaching programming rather than teaching by language features where you do assignment statements, if statements, while statements, etc. So we tried to do a problem orientation. That's where we started. We've early on decided that, oh, wait a minute, this is still a programming class. You have to understand the basics. So whatever we do, even when we're looking at problems and the problem orientation, we want to make sure that our students still come out understanding the basics of programming. So we wanted to have an explicit separate examination of the basics. I think of two of my ideas, or the way I frame part of our work, is that we're looking at sub-skills of programming. And one of those sub-skills, or two of those sub-skills, are problem representation. It seems to me that students don't know how to represent problems when they get to programming languages or programming statements. It's very much like word problems in math, that they can do the math just fine. So if I told them to convert this to code, to write an assignment statement for this, they could do that, but they don't know how to make up what they want to do, how to represent their problem in terms of variables, operators, values, functions, etc. And putting those together is bad. If you've taught spreadsheets, they have problems, or producing their own formulas. They can copy what you want them to do. They can use one-step formulas or looking up a function, but they can't make things happen in any kind of harder way than that. We also thought that conditional expressions, the things that go inside ifs and whiles, that those are hard to produce also. So we're wanting to sort of separate those out as things that are worth attention on their own. And then we're also working on meta-knowledge. In particular, Stephen will be talking in the next session about why can't you solve this problem? Maybe, and some other things. We're thinking about how can we help students think about their programming. So that is one of the main features. One of my students once used the term, you have to think like a programmer, or you need to be able to start thinking like a programmer, and maybe trying to figure out what that means. Okay. So the basics that we talked about, produce and submit a functioning program. If you can't do that, you can't write programs, right? Represent the problem or the problem element, so be able to use simple input process output kinds of problems, and be able to do those. Interpret and produce Boolean expressions, separating that before we do if statements. Stephen actually looked this up in a bunch of textbooks. Pretty much all of the textbooks, none of the textbooks did conditional expressions before ifs. So they do an if statement, which requires a conditional expression, but they don't actually explicitly address how do you build those conditional expressions. So we have separated that out. And then we do conditional execution or if statements and repetition appropriately. So those are the basics. We wanted to make sure all our students had those. And we had encountered some problems in evaluating that before. One is the notion of partial credit. Every time you grade a programming assignment, you never give a kid 0. You always give them partial credit for this and this and this and this. Did they get that piece that you were after? Well, I don't know. They got this score. So at the end, you don't really know. When we start looping, you still have if statements in there and assignment statements, et cetera. So you're having to check that again. So regrading the prior material. Evaluation is troublesome. And in the end, in this case, we never felt like we knew whether or not students were actually getting it, whether they had attained all those basic skills. So we wanted to do something about that. And now Stephen will show you some examples of competency demonstrations. Stephen came up with the idea of mastery learning. I didn't like that term. I called it competency demonstration, or mastery demonstration. I called it competency demonstration. What we do in this is address each of the basics separately.
So wait, quick clarification question. Is this different than Bloom's mastery learning?
Yeah.
Okay, that's cool.
This is show me that you know how to do it, is the way we think about it. Each of these tasks is a pass-fail. Students can redo it without penalty. So if you bomb the first one, that doesn't mean that you have to overcome that 0 on the first one or that F. It just means that you need to do it again till you get it right. And we allow them to redo that with no penalty throughout the whole course, mostly. To pass the course mostly requires passing demonstrating competency on all those basics. And I've started doing this. I don't know if Stephen has yet. This is my primary mechanism for providing feedback. I don't grade homework assignments. I have them do exercises to learn. This is in the context of a visual basic class. I give them a lot of exercises, and they have to produce a project. That's a major grading element for the course. They can't do the project without doing the homework. They can't demonstrate competency on the basics without doing the homework. So I focus my grading here. Okay. So what do we think now? Well, we think grading is much less onerous. Grading's all, I've hated grading. I mean, I've given 20 talks, I think, on how much I hate grading and how bad I am at it. I kind of don't mind grading these competency demos. I look at it and oh, yep, this person gets it. Pass. Oh, no, I don't think they get it. Fail. And so they find out about that rather quickly. They can come talk to me before they redo it. I encourage them to do that, so that's been helpful. The students seem much less intimidated. They recognize that, oh, we'll get a chance to do better. I don't fail because I did poorly. My experience is that I've had up to 4 retakes, which means I have to give them, I have to make up different competency demonstrations, but that doesn't seem too bad. And students aren't going to do the homework just because I tell them they need to necessarily, so I need to work at that a little better to make that happen better. A number of them did. It doesn't start early enough, so I need to do that. But I like this a lot. I'm still working on what I use to have them demonstrate, so I'm revising those constantly every semester. I need to work on getting students need to work on involving them and helping them understand what we're trying to do. And I need to figure out the grading process. My current grade book, I awarded a substantial number of points for each of the 5 competency demonstrations. If they got none of them, they got an F, but they could sort of get a C without getting all of them, so I need to figure that out a little better. But I'm feeling good about it. And so I suggest very strongly that you find yourself a Stephen or a Philip, somebody to talk to. Stephen and I enjoy talking to each other about our teaching of our computing, and you don't know how much better that makes your life if you've not done it a lot. So I encourage that. I have some links here. This will be posted, and the bottom link down there is one to the competency demos that I've used. I don't want to tout them, but they're available and should remain available. I probably will do something somewhat different next time. Thank you. Questions, discussion? Yes, sir.
So do these replace some homeworks or tests, or do you still do the same other assessments that you used to do?
I don't grade the others. So my grade, what I grade is the competency demonstrations, a final exam, and the project, attendance and participation. For 10% for attendance, and if you don't show up, you can't get an A.
What do you do with the students that pass the first one while everybody else is doing 2, 3, and 4?
Typically, the first one I give in class. So the first trial is always done in class. If 90% of them failed it, the 10% kind of get half a day off or whatever, while the others take it the second one in class. But generally, you only get one shot in class, and you have to come after class. I'm in a college environment, so it works better that way. But if you're meeting with the students 5 days a week, or and like you would in high school class, I think that you can still you have a better shot at using class time, and other students can be working on stuff.
Do you find that this encourages students to learn from their mistakes?
I don't know. Students actually come talk to me more now than they did before, because they really do have to come do well on most, if not all of the competency demos. And if they don't understand it, if they fail a couple of them, they recognize then, oh, I don't know this, I better go find something out. And so they come talk to me more than they have in the past. To me, that's the part of teaching I like best, not standing up and talking to them, certainly not grading anything. But when they come talk to me, I love that. I mean, that's the neatest thing that can happen as far as I'm concerned. And so I have found that this gets them into my office a little more than previously. They still do. I think some of them do the homework, but some of them maybe don't. Steven?
I would just add to that and say yes, absolutely. The first time I did it, and I handed back it was great to hand back the results. Half the class failed. I was really nervous about what's going to happen. So here I am telling half the class, you do well enough here. You failed this. And I was expecting a big backlash. I didn't get that at all. So they quickly understood that, oh, so we can do this again, right? Oh yeah, great. You have an opportunity to do this again. And I noticed that when I was doing a retest, what you see out in the classroom before you start is they're kind of shuffling through, looking at their papers. They're really studying what it is that they had done. They're talking to their peers, saying, "I didn't get through it. When did you do this one?" And they're exploring that a lot more. So yeah, I think this does help foster their learning.
It does sort of focus their attention, I think. Yeah.
Yeah, it sounds like it also gives them a good idea of what they really understand and what they don't understand.
Yeah, clearly, because I mark the different pieces as passing or shows understanding or doesn't, and so that clearly communicates to them the pieces that they don't, and they know what they don't understand. They generally know what they don't understand anyway. So what they have to do is talk to me to try to figure out what they don't, if they haven't figured it out with their peers. Okay. Thank you very much.